Right. Good morning, everybody. Sorry for coming a bit behind schedule. Organic and inorganic chemistry class. Want to welcome everybody here. All right. So we've been able to conclude material chemistry last week. So this week we are beginning with electrochemistry, introduction to electrochemistry. So that's what we're beginning today. All right. So for this electrochemistry, we're looking at electrolysis and everything that we need to know as far as electrolysis is concerned. All right. So we'll be defining electrolysis. What is electrolysis? Now, when electricity or current passes through a compound, okay, which is either in solution or molten form, the chemical decomposition of the compound occurs. This is what refers to as electrolysis. Okay. So when an electric current or electricity passes through a compound, okay, now that compound can either be in the form of a solution or in a molten state, and the chemical is being decomposed. Okay, the compound is being decomposed. Okay, that process is referred to as electrolysis. Many of us are already conversant with this in our secondary school, so just want to build from it. Right, what you already know about electrolysis and the rest of them. Okay, so but just understand the fact that electrolysis is when you pass a current into a compound which is either in a solution or in a molten state. Okay, and then the compound is being decomposed. That is referred to as electrolysis. Now, in electrolysis, there are two major things that we need to pay attention to. We have the electrolytes and the non-electrolytes. The electrolytes and non-electrolytes. Okay. Now, for the electrolytes, they are referred to as a compound which either in solution or melting form conducts electric current and is decomposed at the electrodes in the process. So any compound that can conduct electric current, okay, and those compounds are being decomposed in the electrode, that is an electrolyte. Remember, this compound, like we said, can either be from a solution or in a molten form. And then for the non-electrolytes, these are compounds which either in molten or solution does not conduct electric current and is not decomposed. Okay, that's non-electrolyte. Any compound, whether in molten form or solution form, that does not allow the passage of electricity or current through it and they're not decomposed by it, that is non-electrolyte. Okay, so it's very important to know these two points as far as electrolysis is concerned. So examples of electrolytes, we have the acid, we have the base, and we have the salt. Okay, and then for the non-electrolytes, the example is the sugar solution. So a sugar solution does not allow the passage of electricity through it. Okay, so those are the examples of electrolytes. Then we talked about at the electrode, during electrolysis, the composition actually takes place at the electrode. Okay, so what are these electrodes? Electrodes are basically conductors, either made up of metals or carbon, by which electric current can enter or leave the electrolyte. So the means by which electric current actually enters or leaves the electrolyte is referred to as electrode. And there are two types of electrode as we have it. Two types of electrode. We have the cathode and we have the anode. The cathode and the anode. The cathode is a negative electrode, okay, by which the electric current or electricity enters the electrolyte. And once there are also negatively charged electrode. Okay, so that's the cathode. The negative electrode by which electric current enter the electrolyte. They are also known as the negatively charged electrode. We have examples of them, which we're going to look at. Now we'll start the video of the electrolysis of subcompounds. Okay, why the anode? Anode is the positive electrode by which current leaves the electrolyte. They are also known as the positively charged electrode. Positively charged electrode. So those are the two types of electrodes that we have. Like I said, electrodes are conductors, whether metal or carbon, by which electric current leaves these electrolytes. You say there are two types of electrode. We have the cathode, we have the anode. Okay. The cathode is a negative electrode by which current enters the electrolyte. They are also known as negatively charged electrode. While the anode is the positive electrode by which current leaves the electrolyte. They are also known as the positively charged electrode. Now, at the electrode, the following chemical charges takes place. Okay, let's look at what takes place at the electrode, both the cathode and the anode. Now, for the anode, oxidation takes place. Okay, oxidation takes place in the anode, meaning that the ions have to give up the extra electron that they have to become the neutral electron. So these electrons now move from the anode through the battery. Okay. Now, one pattern we're looking at the electrolysis of some compounds, we get to understand it more because I have some diagrams that we used to explain this. But what we're trying to say before example, because anode have an extra electrons at the outermost shell, it can be 1, it can be 2, it can be 3. Okay, what do these are? During electrolysis, oxidation takes place. Okay, now once oxidation takes place at the anode electrode, they give up the electrons. Okay, that extra electrons that they have in the outermost shell, they give it up, thereby they become neutral. Now these electrons that they're giving up now will now move from the anode through the battery. Then at the cathode, production takes place. So the cations now takes up that excess electrons that the anode released, and they also become neutral. Okay, so it's very important to understand these two things that happen at the electrode. So at the anode, oxidation takes place by giving up the extra electrons that they have to become neutral. And these extra electrons move from the anode through the battery. And then it gets to the cathode where reduction takes place. And the cations and the cathode takes up these extra or these excess electrons that we release to also become neutral. Because they need some amount of electrons to become neutral. So that's why they are gaining. Why the anode, they have excess, they have to give it up for them to also become neutral. So these are the two things that happen as far as the electrode is concerned. Okay, let's proceed. So let's look at the electrolysis of acidified water, dilute H2SO4, dilute tetraoxosulfate 6 acid. Let's look at the electrolysis of dilute tetraoxosulfate 6 acid. Okay. Now the apparatus is designed for the collection of precious products. The two electrodes used are the platinum foils. So we have the platinum anode, platinum cathode. So for this electrolysis, we're using platinum foil as the electrode. Okay. So we have both the anode and we also have the cathode. Okay. So that's how the apparatus is being set up. So we have our Hofmann voltmeter. We have the electrodes, which is the platinum foil, with the platinum anode and the platinum cathode. Then we have our battery that supplies the electric current into the system. So we have to now pour in the dilute H2SO4 into via the Hofmann voltmeter. Okay, so it comes in, and then once that is done, the battery that supplies the current, okay, for the electrolysis to take place. Okay, so that's a simple apparatus that is designed actually for that. Okay, so now what happens? Now let's look at now when this is being set up after the dilute H2SO4 has been passed through the of 1 voltmeter and the currents are being passed in, what happens? Now, this is a theory of the theory diagram of the electrolysis of the H2SO4. Okay, if I were to explain this in details, there are certain things that happens. Look at the negative cathode and the positive anode, just like I've explained to you what happens. Okay, so at the cathode, you can discover that hydrogen ions migrate to the cathode. Okay, the hydrogen ions migrate to the cathode and are reduced by gaining electrons to become neutral, just like I told you. At the cathode, what happens? Reduction takes place there, and then they absorb these extra electrons. Now, these electrons are the ones that are being released from the anode. Okay, so at the cathode, the hydrogen ions migrate to the cathode and are reduced by gaining electrons to become neutral, just as I have it there in the diagram. Okay, now once this happens, what happens is now these hydrogen atoms now that migrated to the cathode then combines to form diatomic hydrogen gas molecule. Okay, that's what happens at the cathode. So the hydrogen atoms combine in pairs. Okay, they combine in pairs at the cathode. Okay, to form diatomic hydrogen gas molecules. I'll show you the reaction, chemical equation of this particular experiment, this particular electrolysis, so that it will be clearer from what I'm saying. Now, at the anode, the sulfates, that's the SO4 ions, and the hydroxide ions migrate to the anode. Okay. Now, once they migrate to the anode, the hydrogen ions being lower than the sulfate, okay, in the electrochemical series are being discharged. Okay, they're preferentially discharged because why? The hydroxide ions are lower than that of the sulfates. Okay, so once this preferential discharge actually takes place at the anode. So this therefore will now result to the electrolysis, okay, of this hydrogen, which is being produced. 2 volumes of hydrogen are therefore produced at the cathode. And of course, we have also 1 volume of oxygen that is being emitted, okay, from the anode. So that's exactly what happens, how electrolysis of acidified water, which is the H2SO4, is being taken. All right. For emphasis sake, just like I told you, the negative cathode electrode reaction. Now, for the use of this, the negative cathode electrode reaction is reduction. That means the gain electron. Then the hydrogens are attracted to negative cathode. Then they are connected to hydrogen gas, just like what I've explained to you. Let me show you the reaction. This is it. That's the reaction. Okay, that takes place. Okay, so ionization of the acidified water once you pass current, hydrogen and hydrogen is being released. Okay, they are being ionized as soon as once you pass the electricity to it. Okay, the same thing also happens. Ionization of the H2SO4 releases 2 hydrogen ions and 2 sulfate ions. Just like I told you, the reaction that takes place at the cathode, you can see it. Okay, from excuse me. So you see what I just explained to you, what happens both at the cathode and the anode. Like I told you, at the cathode, the ions migrate to the cathode and are reduced by gaining an electron to become neutral. So you can see how the hydrogen has gained an electron to become neutral. That's a reaction that takes place at the cathode. Okay. Now, once it now gains, once it becomes neutral, the hydrogen atoms will now combine in pairs to form diatomic hydrogen gas molecule. So you can see it. That hydrogen molecule is diatomic because okay, they combine, okay, in pairs. So they pair each other to get the H2, which is diatomic hydrogen. Then, like I explained to you too, at the anode, we said the sulfate ions and the hydroxide ions migrate to the anode. Now, like I told you, the hydroxide ion is lower as far as the electrochemical series is concerned. The hydroxide ions, low, because they are lower than the sulfate ions in the electrochemical series, they are preferentially discharged. So the hydroxide ions are discharged. So once that occurs, you get 2 molecules of hydrogen and 1 molecule of 1 molecule of oxygen. That's what you have after that preferential discharge has occurred. Okay, so that's what happens at the end. So that's just a simple chemical reaction of the electrolysis of acidified water with the H2 SO4. So at the end of the day, the overall equation of electrolysis will now give us 2 molecules of hydrogen, okay, that yielded 2 molecules of hydrogen gas and a molecule of oxygen. So that's simply the electrolysis of acidified water. Okay. So to summarize what we just talked about as far as the electrolysis of acidified water is concerned, we said water is a poor conductor of electricity, but it does contain some hydrogen ions and hydroxide ions. These ions are formed when a small portion of water molecules naturally dissociate. Water is acidified with a little dilute sulfuric acid. So ions attach to the cathode, gains electron and form hydrogen gas. To further explain, hydroxide ions attracted to the anode, they lose electron and form oxygen gas. So the overall balanced equation for the process becomes 2 molecules of water to yield 2 hydrogen gas and a molecule of oxygen gas. Okay, so the volume of hydrogen given off is twice the volume of oxygen that is given off. Just as you can see, 2 molecules of hydrogen gas and 1 molecule of oxygen gas. So I hope that is clear enough. Try to be slow as much as possible so that we can understand exactly what I talk. Okay. So that's all for the electrolysis of acidified water. So I'm going to give an assignment before we continue. From what I've just done, I've just shown you how the electrolysis of dilute H2SO4. So we'll be taking 2 assignments. We're going to do the electrolysis of brine water, which is sodium chloride solution, and of course the electrolysis of copper 2 chloride solution. So we're going to do the electrolysis. There are 3 things I want us to do there. Just follow the pattern I used in doing mine. The first is sketch. Okay, sketch the apparatus. Okay, for the electrolysis of both the brine water and the copper 2 chloride. Identifying the various what electrodes are you, what kind of electrodes are you going to use? I want to see a diagram that shows the apparatus for such electrolysis. Then when you are done, show us the cathode reaction and show us the cathodic reaction and the anodic reaction. So what happens at the cathode, what happens with the anode, and then you also put down the reaction, the chemical reaction, chemical equation, the oxidation and reduction that will take place in the electrodes. Then from there, you can now give us the overall chemical reaction as far as electrolysis is concerned. So 3 things: sketch the apparatus, identifying all the apparatus that is required for such electrolysis, show us the cathodic reaction and the anodic reaction, which will not give us the overall reaction. So you do that for both the brine water, and also do the same thing for the copper 2 chloride solution. All right. My email address is checkbadi@gmail.com. For those that don't have it, email address is check, CHECK. Please write it down. Don't put out to start calling me. I didn't get your email address and that and that and that. If you don't have it, write it down now. Email address is check, as in CHECK, Badi, BARDI, Peter@gmail.com. So they're all together. Check badpeter@gmail.com. So that is my email address. So I expect us to do this assignment before the end of next week. All right, so let's proceed. Factors affecting products of electrolysis. That's what the factors affecting products of electrolysis. Number one is the position of ions in the electrochemical series. That's number one factor that affects products of electrolysis. The position of ion in electrochemical series. Just like I told you, you see what happened during the ionization of H2SO4. Because hydroxide is lower than the sulfate ions in the electrochemical series. You see there was a differential discharge was took place there. Instead of the sulfate being ionized, discharged, hydroxide ions actually was one that got discharged. So the position of the ions in the chemical series is not a factor that affect the product of electrolysis. Okay, according to the electrochemical series, the most positive metal is that which has the greatest tendency to give up its electron. Okay, the most positive metals are the ones that have the highest tendency to give up its electron. So that's number one factor affecting product of electrolysis. Number two is the relative concentration of ions in the electrolyte. The relative concentration of ions in the electrolyte. For example, now if let's say if two competing ions are present at any of the electrodes, okay, if two competing ions are present at any of the electrodes, what's going to happen is that the ions that is more highly concentrated in the solution will be discharged, irrespective of its position in the electrochemical series. I take it again. So this number two has broken the rule of number one, okay, which considers the position of ions in the electrochemical series that will determine the product of the electrolysis. But if there's an ion, let's say for example, there are two ions present at any of the electrodes, the one that is more concentrated in the solution will be the one that will be discharged, whether it is lower in the electrochemical series or not. Okay, so that's another factor that affects product of electrolysis. Excuse me, product of electrolysis. So the relative concentration of ions in the electrochemical series. Then number three is the relative concentration. The nature of electrode used is also another factor that affects electrolysis. The nature of electrode use. Some electrodes do not take part in the electrolytic reaction. As we know, some electrodes don't take part at all. They're not even part of the electrolytic reactions. For example, if you're using an inert electrode, it's not going to take part in the electrolytic reaction. So the nature of electrode used can also determine the product, okay, of the electrolysis. So as such, it becomes a factor affecting products of electrolysis. Now, on the other hand, some electrodes have strong affinity for some ions. Okay, some electrons they have greater affinity. Some electrodes have strong affinity or greater affinity for some ions. Okay, either because they possess certain properties similar to the electrode that is being used, or they possess certain properties that is also similar to those of the ions in the electrolyte. So because of that, they get more attracted. They affect the product of electrolysis. I said three things as far as that third one is concerned, which describes the nature of the electrode used. I said number one, some electrodes don't even play any role. They don't play any role as far as the electrolysis is concerned. So in this case, the electrode does not affect or determine the product of electrolysis. Like I said, for example, if you're using inert electrodes, they don't take part, they don't participate in the reaction, the electrolysis. But on the other hand, if some electrodes On the other hand, there are some electrodes, like I said, some electrodes, they have greater affinity for some ions in the electrolysis, either because the ions possess the same or certain properties like the electrode, they get attracted by, they affect the product of electrolysis. Number one, or it is possible that these ions also have similar properties as those of the ions present in the electrolytes. So these also affect the product of electrolysis. Okay, so that is basically the factors affecting products of electrolysis. So by the time we come back next week, I still have like about 10 minutes to round up this class. But I'll just review, I'm going to review back what we were able to discuss today. By the time we come back next week, we look at the Faradays laws of electrolysis. Okay, I'll just quickly introduce it and then we build this Faraday's law which is from there. Like we know, Michael Faraday was the first person to state the quantitative results of electrolysis. Electrolysis came into existence because of Michael Faraday's work as far as electrolysis is concerned. Okay. Now this he came up with two laws, basically two laws. Now these two laws that Michael Faraday came up with are laws that determine the amount of substances either being liberated at the electrode, okay, or the ones that are being gained, okay, from the electrode. So because of this, he came up with some laws that fell into three factors, okay, which include the magnitude of the current that is passed, the time of flow of this current. Number three, the charge of the ions, the elements vibrated. Those are the three factors that Michael Faraday considered before he came up with the laws of electrolysis. Okay, let me repeat what I just said. I said Michael Faraday was the first person to state the quantitative results of electrolysis. After I carried out a lot of experiments with electrolysis. Okay. Now, these laws actually states that the amount of substances liberated at the electrode depends on three factors. Okay, the laws that he came up with actually stated that they are basically that the amount of substance being liberated at the electrode depends on three factors. What are these three factors? The first is the magnitude of the steady current passed. What amount of current is being passed to the electricity? That's number one. Then number two, the time of flow, the steady current. Okay, and then number three is the charge on the ions of the element that have been liberated. So those are the three factors that Michael Faraday actually put up together to bring us the laws of electrolysis. Okay, so hopefully we'll be building that from there. By next week we'll look at these laws of electrolysis and then we'll understand it better according to what Michael Faraday did. So a quick summary before we call it a day. We looked at electrolysis, okay, electrochemicals, electrolysis, okay, and we defined electrolysis. Okay. So, if you talk, I'm not green. Yes, I have it. Okay, sorry. So we defined electrolysis, and then we looked at the electrolytes and the non-electrolytes. We also looked at the electrodes that are usually used during electrolysis. We classified the electrodes into two. We have the cathode electrode. We also have the anode electrode. Except for the electrolytes, those that can allow the passage of current, okay, through the compound, and they are either they are usually decomposed at the end of the day. Examples like the acid, the base, and the salt. Then for the non-electrolytes, those that don't allow the passage of electricity or electric currents, and they are not decomposed. So we give example of a sugar solution. And then for the electrodes, these are conductors, either made of metals or carbon. Okay, and this is where electrical current either enters or leaves the electrode. There are basically two types of electrode. We have the anode and we have the cathode. We said the anode is the positive electrode, while the cathode is the negative electrode. So the anode being the positive electrode, the electrons leave, okay, and enters through the cathode, the negatively charged. Okay, so we looked at the cathode and of course the anode, and then at the end of the day, we now looked at the electrolysis of brine water, which is the dilute H2. So what happens with the cathode, and of course the anode. Alright. So by next week, we'll be looking at Faraday's laws of electrolysis. I think there's something I missed out before we enter that brine water, which is the ionic theory, and of course, what makes a strong electrolyte. What makes it electrolyte. So we'll just start from there next week. We'll talk with that. Talk and then look at Faraday's laws of electrolysis. So that will bring us to the end of today's class. So remember the assignment I gave. I gave two assignments, which is the electrolysis of brine water, sodium chloride solution. So do an electrolysis of sodium chloride solution, NaCl solution. Draw, sketch the apparatus, okay, and then tell us what happens at both the cathode and the anode. The apparatus should be able to identify the electrode you're using for such electrolysis, okay. Then tell us what happens at the cathode and the anode. Then give us a general electrolytic reaction. We do the same thing for the electrolysis of copper to chloride solution. Okay. As soon as you do this, you please submit it to my mail before the end of next week. Alright, so that brings us to an end of today's class. I think we'll continue from here next week. Thank you so much for the time.